Okay, good morning, everyone. I hope you had a good time yesterday with the choice of rum and cheese and everything, and fully recovered today. So thanks for coming. You are in a green room. We have a splendid session laid out for you this morning. And the first one is the presentation from a very interesting team which splits the industry and the academia. And on the stage we have one of the co-authors, which is Stephan from Fraunhofer University in Germany. But on the team also a couple of my colleagues from Intel Security. And when I was reviewing this paper, I thought it was particularly interesting, so I was very pleased that Virus Bulletin put me as a moderator for this session. So, without further ado, Stephan, over to you, and please welcome him.
Okay, hello. Welcome for my talk. As Igor said, my name is Stephan Huber. I'm from the Fraunhofer Institute for Secure Information Technology. And today I want to speak about some Android malware, which is abusing backend as a service for command communication, command and control, communication over some cloud. I'm just a replacement speaker for this project, and therefore at first want to introduce some person who do the main work of the project. So the lead and the idea was from Siegfried Rasthofer. He's a PhD student at the Technical University of Darmstadt, and his research focus are static and dynamic code analysis. And he belongs to the group of Professor Bodden, who is also professor at the Technical University and also the group leader for secure software engineering at the Fraunhofer Institute. And as Igor already said, this was a collaboration with Intel Security. The responsible analyst of the application was Castillo, and he belongs to the group of Alex. Okay. How was this idea born? The idea was born a few months ago when we discovered a small implementation flaw in a normal Android application. The application was storing some, I think, traveling data in the cloud or in a backend as a service data storage. And we were curious if there are some other benign application also containing this implementation flaw, and we decided to develop some automatic analyze and try to find other benign application. So we analyzed around 400,000 Android application. It's around 1/3 of the current Android or Google Play Store. And there, due to this implementation flaw, we could access to around 56 million backend data consisting of different information. More details about this flaw and attack will be published in a few months at the Black Hat. And the next step was, on one side, we want to test how good our analysis, and we thought also to put or analyze malware applications, because malware applications are a more higher challenge for automatic analysis due to obfuscation and so on. This was the first thing, and the other thing was when we can access the backend of the malware, which kind of data will we find at the backend? Can we find some SMS information, banking, or the command and control and so on? As I already mentioned, I think backend as a service is nothing new for you. It's just infrastructure provided by some companies like databases or administration. In our study, we considered currently three famous backend providers. The first one was BaaS. BaaS now belongs to Facebook, the Amazon Web Services, and Cloud9. Some interesting services for the app developer are the push notification. They also provide a backend like for data storage, databases, or file system. You also can handle user administration or build interfaces for social network integration. The first two features are, for our purpose, the most interesting because on the push notification, you can send messages directly to the smartphone or to the application, and the data storage, as the name says, provides the backend for storing the data. Okay, how can this backend be used, and where is the implementation flaw, the most authors or the most failure? For use, for example, this backend, you have only three comments. At first, you have to initialize the API. Then you can create a new table. In this case, it's called intercepted SMS. And then you can use the key value system to store your information. The big misunderstanding or the problem is now the application ID and the client ID are hard-coded in the application for communicating with the backend. And this is not a real authentication. So you can imagine the authors store their authentication credentials hard-coded in the application. So if you can extract this information, you have full access to the database and the backend because they do not proper access control on the server. The first problem is the provider of this backend provides these features, but if you read the instruction tutorials, you always have only 3 steps. These are the 3 steps you see, and nobody thinks about the consequence or security. So, as I already mentioned, we developed some analyzer to detect this implementation flaw, and I'll first give a short overview how this is working. At the input, as you can see, you have the APK files we want to analyze. At first, we do some lightweight library detection to filter out all applications which do not contain any API calls or library to communicate with the backend. Then the second step is the most important step, is to try to extract the keys automatically. This extraction phase is separated in a static and dynamic phase, and the static phase can be also separated in 2 phases. In the first step, we just do some simple constant propagation to the initialize method to find if the keys are constant defined. If there are the keys defined as some constant, the analyzing is done because we have the key values. But there are also, especially in malware, there are some kind of obfuscation or the keys dynamically generated, for example, encoded in a byte array, or the different characters are connected during runtime. And at this problem, a normal static analyze fails. So the second phase of the static analyze is some slicer. The slicer just extracts dependent code for this API call. And then the extracted code will be injected in some runtime environment. The advantage is now we can reach code coverage, because normally if you want to dynamically analyze something, you always have to consider external influence. For example, is there a button? Do I have to click the button 1 time, 2 times? Is there some combination? Is there some timer or some special condition? How can I say, code rubbish is all thrown away, so we just have the core responsible for the parse communication, for example. And then this code part is executed, and we can extract during the runtime these features. In the next step, we also, with the same technique, try to extract the table name, merge this in some, here we called it some exploit generator, and then we have some client or application which can automatically try to connect to the database. So now I want to go a bit more in detail to the malware aspect. Here we found some malware using the Facebook's parse backend infrastructure. We got around 300,000 malware apps from Intel Security during our analysis. And we found around 80 apps which abuse the push notification, 16 applications using the data storage, and 5 of these were the Android obfuscated malware. 4 were Android Mary variants, and we extracted from the 5 obfuscated variants 5 parse accounts. With these accounts, we make further or more detailed analysis, which we'll explain a bit later. And for this analysis, we extracted 3 common tables, and these 3 common tables are the core point of the command and control communication. Okay, at first I'll give a coarse-grained overview how the application or the malware internally is working. The app itself is just will be executed and launches some service. Then it hides the icon, and this was the whole process. Then the application will react on different external events, like if the phone is ringing or if the boot process is completed, and will save some command and control URL, and then executes or spawns some background tasks. The application has then subscribed or logs into the parse backend and sends some push notification that the application is let's say, online with some information. Then it saves some additional install information, and it also, how can I say, the malware uses 2 communication ways. It also makes a connection to some plain command and control server, in this case some web server, but this context we will currently ignore in this talk. Okay, and then it registers some scheduled system alert. This is something like a scheduled task which will be called every X minutes to handle something. Okay, as I said, this system alert will be executed every minute, and it first tries to establish the communication to the, as I said, plain command and control backend. The other option is now using the parse backend. There we have the first table. This table is called new tasks, and this new task table works as kind of command interface. So every command which should be sent to the malware is just simply stored in this table. So the process of the plain backend, you can see here the whole overview. I will not explain it in detail. I think the slides are published, and this interaction is just a subset of the other branch which will be handled over the parse communication. So at first the application tries to compare the device ID with the EMI, because the EMI works as the unique identifier, or you also can say as the primary key in the comment backend. So it looks okay, looks for the EMI of the device in the table and says, okay, for this ID is a comment. So okay, I can receive the corresponding comment and execute it. So as I said, if this comment matches, there will be executed a new task. When the task will be executed, the execution of the task will be saved in a new table. This new table is called task manager table. You can see this table as a kind of response. So as I said, the new tasks will be the comment sent, and the task manager will be the result or response of the new task. How can the different tasks look like? At first, there's some interception function. If this interception function is turned on, every SMS which is sent from the device or received from the device can be intercepted or eavesdropped, and will be also stored in the backend. There's an additional table, this is called SMS received, and in this parse backend table, the received SMS are stored. We also get access to this table and later analyze, but there I'll get later in detail. Here you see an overview of the different tasks and functionality the malware can do. As I already said, it can intercept SMS, but it also can send SMS, for example, for providing or distributing the malware or doing some smishing attacks. You can send USSD codes. You can also provide some fake URLs to the browser. You also can install new application. We also observed that the obfuscated will install a new variant called the Mary variant. For the install process are also 2 ways. On the first way would be just using the plain Android installer. The other way will be check if the device is rooted. And if there are root privileges, the app tries to install it with a hidden install process. Another important point is if a task is executed or a command and written to the new task table, it will be deleted. So this is like a command queue. So else you would end in a deadlock because the new command is not removed from the command queue. As I already said, there's also some functionality for intercepting SMS messages. Here you see the backend handling for the SMS. As I said, the received messages are handled in two ways. On the one side, they are stored in the backend, in the SMS receiver table, and they also send it via push message. Here in the next step, I now try to explain the different database schemes, or you also can see or can interpret it as the command and control protocol. So as I said, the new task record just is separated in an email, in a task column. The last three columns, the object ID created and updated, are default columns always created by the parse backend. And the tasks, as I already mentioned, can be separated in the SMS task, intercepting task, providing new server URL for command and control, or installing new applications. Here are now a few statistics. Because we had access to this parse backend, we could download the table, and the table structure is very easy to analyze and to evaluate it in, let's say, Excel, and to get statistics. We considered the 5 accounts named A till E, and there you can see the number of different tasks. The interesting thing is now, if you look at account D, there is nearly no task. This is because, as I already said, the new tasks is the command queue, where the new commands are provided. And if the command would be executed, it's removed from the from this table and written in the other tables. So you can see account A, B, and C and E have a lot of commands in the queue, and account D already has processed all the commands. Here are, for example, some samples how such a command can look. For example, for the SMS, the first example is, or says, if the device receives an SMS, for example, containing or the number 900 with the content balance, intercept this SMS and store the copy. This is this belongs to some Russian bank, where you can make your bank account balance requests. Or there are also some commandos which will try to steal credit cards. They are implemented with some regular expression. This means if there's an SMS sent from this number containing a credit card number, store the credit card number. Or the intercept command, as I said, just activates or enables or disables the interception. Here is a commando to provide new command and control server, or also to install new applications on the device. We also made a statistic about the distribution over the time, because as you saw in the table scheme, in the previous table scheme, there's always stored the date when the entry is made. And there you can see the increasing amount of the different distribution. Here is the scheme for the received SMS. You can see at the first the body. The body is just the content of the SMS, which was intercepted. Then from, this is the origin. Then the in type classifies if it was an incoming or outgoing SMS. The receiver, there's also an option, especially for credit card. If it's enabled, it will pass the message for credit card numbers. And there's also some type, which currently Carlos, the analyst, says it has two different types, other and service. Here are a few samples or numbers about the received SMSs we got from the backend. Yeah, I think they're self-explaining. Here are some credit card numbers we found. And here, this is the other table. This is the opposite of the first table. Here you see now the task manager or the executed comments, and as you can see, account D has executed all its received comments. These are, for example, then the result of executed comments. So, for example, the beginning we had the command, please intercept the number 900. Here, then you get the result for the number 900. Here it's the Sberbank, or for another company, Megaphone, or the results of some smishing attacks, the SMS sent to someone containing some URL for distributing the malware. Here we found, depending of the target phone numbers, we had a small statistic about targeted companies. As I said, there's some bank. Also, you find some telephone providers and some other banks. It also was interesting because, as I said, the email or the unique ID of the device works as primary key in the command structure. So we just counted the distinguished or the unique IDs and get a number of, and can get very easy a number of all the infected devices. I just should mention the most infected devices were in the Russian area. The last thing was now the responsible disclosure. My colleague said I should say something about it because it was a bit of funny. Because, as I said, BaaS belongs to Facebook, so we tried to contact Facebook and to announce our findings and that they should make any countermeasures. And the first reaction, just when we announced it, the first reaction was, you don't get any money from us. This is not a bug bounty. We just said, we don't want any money, we just want to announce the problem. After that, they asked for more details, then the responsible disclosure was okay. The funniest thing is now, we at first tried it by email, but you cannot do this with Facebook. If you want to announce something to Facebook, you need a Facebook account and send a Facebook message. Also, the response of the information and the whole communication is only done by Facebook messaging. And if you now have some critical information, I don't know if you can include any PHP or SMIME keys in Facebook message service, but I think this is not the best way to do responsible disclosure processes. Conclusion. Yeah, this Trojan was especially targeted for Eastern Europe banks. The problem or the security problem is not just considering benign apps, also malware or authors make or have failures. And the other problem is now when the sensitive informations are stored in the backend, as I showed, the credentials are hard-coded. So also this stolen information are just public available. So you don't need any special hacking skills or something. You just can take out the credentials and have access to all the informations the cybercrimes steal. If there are some further or detailed questions, I have also put the contact information for the leader of the project. So feel free. If I can answer the questions, I also, yeah. That's all. Thank you for your attention.
Thank you, Stephan.
Yeah.
We have a few minutes for questions, so if you have any, please fire away, raise your hand. Actually, I had one. Yeah. You looked at these accounts in malware. Yeah. Wouldn't it be interesting to also draw all the benign applications and see if developers expose their access credentials there and leak some privacy data outside of malware field? Did you have any plans like that? Is it even possible?
Yeah, we already have done it. This will be proposed by Siegfried at the Black Hat. There will be, I think, in next month or so, will be Black Hat Europe. and he will talk about this topic on the Black Hat, because there it's more critical. But as I said, we found millions of public available sensitive informations. Also, personal data, also health information, just some traveling information, credit card numbers, pictures of people from how are they called, partner services, and yeah, a lot of stuff.
Okay. Yeah. There is a question here in the middle. Please wait for the microphone.
Thanks for your presentation. Enjoyed it.
Yep.
Do you have any theories as to why certain regions of banks were targeted in your findings? Eastern European, why there?
Oh, this is a good question. Why there? I think the main target is always the SMS banking process. I think there, how can I say, you're doing your banking business, doing by SMS, checking your account balance, doing credit card transfers done there, everything by SMS. And so I think this is a reliable target. And we also made some coarse-grained language analysis with some script about the SMS text. And so we found out that the main region was the Russian area. Also the targeted banks, I don't know them, but I assume, or as the analyst says, they are more settled in the Russian areas. We found a few or other SMS keep in Chinese or also in English, but this was just some, hello, how are you? Do you have some time today or something like that?
Any more questions? Okay, if none, then thanks again to Stephan.